Now let us start with the third quadrant number, magnetic quadrant number, and this quadrant number is represented by the letter M. And here, as we have discussed earlier, that how the subcells may be again further subdivided into orbitals. That is the main theme of this particular magnetic quadrant number. Number second, we are talking about the orbitals here and how these orbitals are having their orientation, and the orientation of them is under the effect of magnetic field, or we can say in other words under the influence of magnetic field. And the third point that we have to discuss here, that is regarding the values of them. What may be the possible values of this magnetic quantum number? And as we are knowing that the values of magnetic quantum number are depending upon the values of azimuthal quantum number. Now here, just let us see if these are the possible values of L. What may be the possible values of L? And here we said that the values of magnetic quantum numbers may be ranging from 0 to 1 to 0 to minus 1. That means here it will be having a total of 2L plus 1 values. And depending upon this formula or this particular factor, we are going to see that if this is the possible value of L, what may be the possible value of L. For example, if L is equal to 0, for example, that is representing the S subcell. So 2 into 0, that is 0. That means here we are going to get only one possible value. So this L is equal to 0 means it is representing the S subcell. And this S subcell will be having only one possible orientation, and that is the one possible orientation, and that is the S orbital. Or we can say in other words as S orbital. Or we can say in other words there is only one possible orientation of the S orbital. Similarly, if L is equal to 1, again if you are keeping the value here, 2 into 1, that is 2 plus 3, that is 3 value. So here we are getting 3 possible values. So the P subcell will be having 3 possible orientation. And therefore we said that how the P orbital can be represented as Px, Py and Pz orbital. So these are three possible orientations of the P orbital. We can represent them as Px, Py and Pz. And here it is the S orbital. How the S orbital is having only one possible orientation. How the P orbital is having 3 possible orientations. Similarly, if L is equal to 3, that time we say that it is the D orbital. Now again here, we say that the values of M may be minus 2, minus 1, 0, 1 and 2. That means here we say that there are 5 possible orientations of the D orbital, which can be represented as dxy, dxz, dyz, dx square minus y square and dz square. So depending upon the values of M, L, we have seen that if these are representing the different subcells, then these values of M, they are representing the orbitals. That the S orbital is having only one possible orientation, the P orbital is having 3 possible orientation, the D orbital is having 5 possible orientations, and so on. So once again the short revision of that. So here when we talk about the magnetic quantum number, that time we have to talk about that how the subcells can be further subdividing the orbitals, then how the orbitals are having their orientation under the effect of magnetic field, then what may be the possible values of L. If the value of L is equal to 1, 0, that time you say that there is only one possible orientation of the s orbital. If the value of p, if L is equal to 1, that time we said that there are the p orbitals having three possible orientations, and this can be represented by this particular formula 2L plus 1, that is the total value of L. Similarly, the third one, if L is equal to 2, that time we are saying that this is representing the d orbital, and here we say that these are the 5 possible orientations of the d orbital and so on. So in this way, we have collected some information regarding the spin quantum number, and then we are going to go to the last quantum number, and that is the spin quantum number. And here when we talk about the spin quantum number, that time we are saying that it is represented by the small letter s. Now we are going to move to the last quantum number, that is the spin quantum number, which is something different in regard to the first three quantum numbers. And now here the first thing that we have to keep in mind is that we have to talk about the electron. How the electron rotates, or how the electron revolves around the nucleus, revolves or rotates around the nucleus. Here you have to see that how it is moving around the nucleus, or you can draw this particular diagram that how the electron is moving around the nucleus. So for example, here we are knowing that our planet Earth, it is moving on its own axis. Similarly, here also we have to assume that the electron is revolving or it is rotating around its own axis. Now here the second point that we have to discuss here, that what may be the two possible values of them, or how may be the direction of the spin quantum number, or regarding the spins of them. And here we said that here the electron rotates or revolves around the nucleus. Then the second point we are talking about the spins of them, and here we said that the electron can spin in two directions, either in the clockwise direction or either in the anti-clockwise direction. So here we can say that it is spinning in the clockwise direction or either it is spinning in the anti-clockwise direction. So these are the two, anti-clockwise direction or the clockwise direction. And here, depending upon the directions here, we say that there are two possible values of S, and these values may be plus half and minus half. So here we say that these are the two possible values of S, plus half and minus half. Again here the question may come in your mind that why these are the two values of them. For example here, if you take the difference of these two, minus plus half and minus half, that time the sum of it will is equal to 1 or unity. And therefore these are the two possible values of S plus half and minus half. And therefore we said that it can be spinning either in the clockwise direction or either in the anti-clockwise directions. Now here the question may come in your mind that what are these particular two signs are representing, plus half and minus half. Plus half, that means here it is the electron is spinning in the direction of the magnetic field. And minus or negative sign indicates here that it is moving against the magnetic field. So this may be the two possible values of S, plus half and minus half. Or we can say in other words that if we are taking the sum of these two, that time the sum of these two may be equal to 1 or unity. So in this way, this is a short information about the spin quantum numbers, that how the electrons are spinning or having the rotations of them in the clockwise direction, anti-clockwise direction, and how these are the two possible values of S. So in this way, we have covered the spin quantum number and in short I will be just briefing you the quantum numbers, what are quantum numbers in short, the types of them, and here again I will be going back to this particular part. Here when we are talking about the quantum numbers, that time we have seen the definition of it, that how these quantum numbers are the identification numbers and how they are giving the location and energy of an electron. Then we have seen the types of them. In the types we have seen the first type is the principal quantum number, that is represented by the letter M. The second quantum number, that is represented by the letter L. The third quantum number by M. Then we have seen that how the values of magnetic quantum number are depending upon the values of azimuthal quantum number, how the values of azimuthal quantum numbers are depending upon the values of principal quantum numbers. Then we have seen how the principal quantum number represents only the cells, how the azimuthal quantum numbers are representing only the subcells, how the magnetic quantum numbers are only representing the different orientations of the orbital. It may be S, it may be P, it may be D, it may be F orbital. And finally, the last one, that is spin quantum number, how the electron spins in the clockwise direction or anti-clockwise direction. So in this way we have covered an important article from the examination point of view, and that is quantum numbers and their types.